We are still on the 2024 University of Florida Integration B qualifying round, part 3, and problem 26 is our focus today, which is a definite integral from x equals to 0 to x equals to infinity of the natural logarithm of x times the natural logarithm of x plus 1 over 1 plus x squared. So this is a very, very interesting problem, and it's my hope and desire that it helps somebody out there. So before we move forward into the solution phase of this problem, I'd like to encourage anyone who may not have subscribed to our channel to please consider subscribing to our channel. Your help in increasing the profile of this channel will be much appreciated. Without much ado, we shall move forward to the solution phase. So yeah, let's move. The problem that we're going to focus on is the integral from 0 to infinity of the natural logarithm of x times the natural logarithm of x plus 1 over 1 plus x squared. So this integral can be split into the 0 to 1 domain and the 1 to infinity domain. Right? And so let's focus on this part here for a minute. Is that when we have 1 to infinity of this can be represented also as negative, right? That's x times open bracket 1 over x plus 1 over 1 over x squared plus 1 dx over x squared. So this is the same as 1 to infinity. And inside here we have negative dx over x squared. Let's put this in bracket. Over 1 plus 1 over x squared. So this guy here can be expressed as a negative. So this is negative 1 over x, like that. 1 plus 1 over x over 1 plus 1 over x squared negative dx over x squared, like that. So I think we've come to a good point. Let me just rewrite this. 1 to infinity 1 over x negative 1 over x plus 1 plus 1 over x over 1 plus 1 over x squared. Then here we can say let u be equal to 1 over x such that du dx is equal to negative 1 over x squared such that du is equal to that. And there's a reason that we did that. When x equals to 1, u is equals to 1. When x tends to infinity, u tends to 0. So therefore, our problem becomes 1 to 0 ln of u negative ln of u plus ln of 1 plus u 1 plus u squared du. Okay, so if say that this has come to 1, 0 ln of u negative ln of u plus ln of 1 plus u du over 1 plus u squared. To flip it, we get 0, 1, flip the intervals, we have ln of u so it means that now this and this interact, so we have positive ln squared of u over 1 plus u squared, and this and that becomes so we realize that this guy here will cancel with our. We had said our integral from 0 to infinity of natural logarithm of x, natural logarithm of 1 plus x over 1 plus x squared was equal to 0 to 1 and x. I mean, we don't really mind about plus the order. And then we saw that this now has become um, and we see that this and that would cancel, so we effectively are left with so since this is our problem 0 to 1 natural logarithm of 1 plus x squared, we can say let u be equal to natural logarithm of x, which means that du dx is equal to 1 over x, meaning that x du is equal to dx, which is eu du is equal to dx. Okay, and so 0 to 1 becomes from here limit at the 0 side negative infinity, that, and then u squared over 1 plus e to the power 2u and then we have eu du. Okay, so this is u squared and we can change around the sign, so we have that 0 u squared e negative u prime 1 plus e2u prime negative du prime. And we can use that to flip the sign around, so we have 0 infinity u squared e 1 plus with a negative there, negative 2u prime. We'll take it back to the x. It's easy to use. So we've come to integral from x equals to 0 to infinity of x squared e to the x 1 plus e to the power negative 2x. So since we know using geometric progression that if you have summation from when k equals to 0 to infinity of a constant ratio term x to the k, this is 1 over 1 minus x. This is when x is less than 1. Since we know that, we see that this term here befits that, but then we have x e to the negative x summation from k equals to 0 to infinity of negative 1 to the k, and we have e to the power 2kx. So, and when you're integrating a sum of things, is the same as the sum of the integration of the independent things you're integrating or summing. So we have summation from that, and we can pull our constant out here so that now our integration is a nice integral here. And we can focus on this and then show that our summation from k equals 0 to infinity, negative 1k, 0, infinity, x squared e to k plus 1 dx. This is the same as 0 to infinity, x squared derivative of negative 1 over 2k plus 1 e to the power 2k plus 1 x. So using integration by parts, where if you have a product of a function v and a derivative of a function u, when that is integrated, you have uv minus u times a derivative of function v. Using that, we have 0 to that, negative 1 to the k, and so our uv will be negative x squared over 2k plus 1 e to the power negative 2k plus 1 x 0 to infinity. When x tends to infinity, this goes to 0. When x tends to 0, this goes to 0. So this entire term goes to 0. And so we have minus minus, because we have a minus here, so this becomes a positive. E to the power negative 2k plus 1 x over 2k plus 1 times the derivative of x squared from 0 to infinity, close big brackets. So this means that we have the summation from 0 to infinity of negative 1 to the k, and we can say we have 2 over 2k plus 1, 0 to infinity, x e to the power 2k plus 1 x. Again, this can be represented as over 2k plus 1, 0 infinity, x times the derivative of negative 1 over 2k plus 1, k plus 1, x dx. Using, again, integration by parts, we have 0, negative 1 to the k, 2 over 2k plus 1, and negative x over 2k plus 1, e negative 2k plus 1, x 0 infinity, plus 1 over 2k plus 1, 0, infinity, x, not x, but let's delete this. Get your 2k plus 1 times the derivative of x. So this goes to 0 again, because as x tends to infinity, this tends to 0. When x tends to 0, this tends to 0. So in other words, we have come to a point where we have summation with 0 to infinity of negative 1, 2k plus 1 squared, 0 to infinity, e to the power negative 2k plus 1 x. So this is the same as when k is equal to 0 to infinity, and this is the power k, negative 1 to the k, 2 2k plus 1 squared, negative 1 over 2k plus 1, negative 2k plus 1, x, 0, infinity. So as we can see, this is the same as k plus 1 squared. Limit as n tends to infinity, this goes to 0, so we have 0, minus minus, as this goes to 0, as x tends to 0, this goes to 1 over 2k plus 1. This and that interact, we have a plus, so essentially we do have the summation from k equals to 0 to infinity of negative 1 to the k, 2k plus 1 cube. So this becomes 2 summation 0 to k over 2k plus 1 cubic, or cube. So in other words, the integral from 0 to infinity of the natural logarithm of x times the natural logarithm of 1 plus x. Let me just delete that so that we have a clear representation. Over 1 plus x squared is equals to twice the summation from k equals to 0 to infinity of negative 1 to the k over 2k plus 1 cubic, or cube, which is the same as pi cube over 16. Now, how these are connected, that will I'll leave it to you to figure that out, but this is our answer. So this has been an absolute pleasure solving this and connecting the question to this answer. If you have any questions regarding any steps we undertook, please feel free to reach out to us or leave a comment in the comment section. But this has been an absolute pleasure. It's a very interesting problem. Until next time, bye bye and be blessed.